right? I'm being told by our technical team that we can go ahead. We have the green light for the retransmission. So let me please start by welcoming everyone to today's session, Back to the Future of the Nuclear Industry, all in the umbrella of the European Nuclear Young Generation Forum 2021. Which is a congress that will be organized by Jóvenes Nucleares, the Spanish Nuclear Young Generation Forum. My name is Francisco Suarez. I humbly serve as a co-chair in the Spanish Young Generation Network and chair for ENYGF. And here together with me today, we have our fabulous hot topic managers. We're going to define what a hot topic is in the framework of ENYGF. They are, you can see it in the screen, Alba Valls, David Garcia, that are taking care of well, I'm not going to say the topics until a bit better, and they're going to get in more detail right away. We also have Alejandro Carrasco, Samantha Estevez, and Roberto Garcia. So what is all of this European Nuclear Young Generation Forum about? The European Nuclear Young Generation Forum is a major event that happens every 2 years in Europe. It's an international congress where basically the young professionals and those to become take the stage in the nuclear sector. And we have been fortunate enough to be the host of the 2021 edition that will be celebrated in Tarragona, in Spain. It's a city near Barcelona. We're doing it in a hybrid format this time due to the recent circumstances that we all have to go through with the pandemic. And we have it planned for the last week of September, as you can see there in the screen. This is all a joint effort. We're organizing it in cooperation with the International Atomic Energy Agency, with our colleagues from Jóvenes Nucleares in Spain, and with our colleagues from the European Nuclear Society, the Young Generation Network. Here in the screen, you can see a link to our website where you can find more information. And I'd like to thank all of the organizing team and everyone that is supporting this initiative for the young generation, and particularly thank our hot topic managers, which are here with us today to tell you a bit more detail about their hot topics. So what is this of the hot topics? The 2021 edition of ENYGF has bet strongly on the innovation to forge it so that the core content is based on 4 hot topics, which are foreseen to be the key topics for the coming decade in the nuclear sector. All those topics all of us should be aware of, because they are going to be pretty much or are expected to have an important role in the coming decade. Without then further ado, now let's start with our first hot topic, which is radioactive waste closing the circle. And for that, we have here with us today hot topic managers of that project, Alba and David, who are going to tell you a bit more about it. The idea that we're going to do is, for every hot topic, the hot topics managers will come in. They will give a brief talk on that subject matter. After we cover the 4 hot topics, we'll open the floor for a Q&A so that you can interact with the hot topic managers, which are working really hard to bring the experts also to our forum and are digging really deep into these hot topics. So let's give the floor to Alba and David, and let's get into the first hot topic, radioactive waste management.
Thank you very much, Paco, for this very kind introduction and very nice introduction of the Congress. I get some problems with the microphone, but I think that it's working. You can hear me, right?
Yeah.
Okay, perfect. Thank you. So I will give just brief details about this hot topic. It's radioactive waste management, and the title is Closing the Circle is just to highlight that we would like to think in what we have in our hands right now and not just throwing the ball to the next generation. So this is the most important for us. We have different challenge among the contents of this topic that we can face. Here we are highlighting in this slide one of them, which is the DGR or DGP, as it's stated here, which is the Geological Repository concept. What you can see here, it's one picture from Finland, which is one of the most advanced countries dealing with these things. And you may ask, what is a DGR, for example, or which is a challenge of making this kind of systems. So it's a big challenging, and we really think that we will have a lot of work in this kind of things in the future. A DGR is basically a system where we are disposing the waste in the geosphere. Basically, we make different galleries and holes, and we put the waste there with different barriers, as you can see in the pictures down in the slide. Which kind of barriers we could have there? Different and several, just to allow the safety of these waste and just to control that there is no release of this in the geosphere and the biosphere. Okay. Which other things may be interesting that we think that could be interesting and a challenge for the future for us? Basically, things related to the geochemistry of uranium, which is also one of the topics included in these rat waste management things. Also, the decommissioning issues, which are something that, of course, as nuclear power plants are closing, we have to deal with this kind of stuff, and this is a very important topic also within this rat waste management hot topic. There's also different topics related with the spellful reprocessing or with this low and intermediate level waste management, which is not for DGP, which is for high-level waste, but it's something similar, some kind of system similar. And also we are going for some kind of environmental remediation of sites. So that's also a very challenging topic for us. And I think that it could be very nice to have different talks about this in this hot topic. If you could pass the next slide, Paco. Yeah, that's the planning for the DGP. That was just to highlight that making a DGP is not just making a hole in the ground and put the waste there. No, there are different phases to build up this kind of facility, and it's something that it's very well regulated, and we have to face different challenges, not just the making the hole. Let's just see here, for example, things like site evaluation, the site characterization. This is all related with the site, but there are other, for example, like things related with I'm sorry, I get a problem here with my kid. Alba, could you follow this? Or sorry, now it's on.
That's okay, David. That's all right.
Sorry. So as I was saying, there are different things with DGR which are important, not just the set selection or the site evaluation, but also the public perception, which is something that sometimes not very well thinking about the people who is working on this. But it's important to also tackle this kind of things. And yeah, basically that was just to highlight that there are different things just with the DGR which are important for us. And I think that should be all to put about this hot topic, Paco.
Thank you for the well wrapped up summary. I know you can go along for many more minutes and hours on your topic. Let me ask you just a quick question before we move on to the next hot topic. Here in the DGRs, we're speaking on pretty long time frames, and there are many topics related to that. But I'd like to ask you a bit on the retrievability aspect of the material that would actually be stored there. Are there options to retrieve it in the future? Can we do something with it? Is this a challenge? What do you think?
That's something important, and it's a very nice question indeed. because yes, it could be retrieved. That should be retrieved. In fact, when these new generation reactors will come out, the ones that can use this kind of spent fuel. And in fact, several of the projects that are running right now are taking into account this kind of systems. So they are designing the repositories in a way they can allow not just to put the waste inside the repository, but also to take it out without any kind of hazard to the persons or the humans that will be making the work, but also trying to avoid any kind of problem with the environment. Especially, I would like to highlight the French case. They are making a very ANDRA, which is the waste management agency for France. They are making a very big investment in this kind of retrievability system because they are pushing a lot for this kind of technology.
Thank you very much. Thank you very much. We will definitely stay tuned onto this hot topic and looking forward for more. Thank you, David and Alba, for your work here. Let's move on to the next hot topic, which is energy transition, and particularly the role of nuclear in energy transition. For this, we have with us Roberto, which is our hot topic manager for energy transition. So Roberto, please, the floor is yours for a summary on this hot topic.
Okay, thanks, Paco, and hi everyone. The role of nuclear power in the energy transition is really relevant because the European Union has said that nuclear energy is one of the pillars of the energy transition in Europe, because the objective, the goal of the European Union is to reduce in 2050 the 85% of the energy related to CO2 emissions relative to 1990. And for this reason, the forecast of the European Union for 2050 is that nuclear energy will have an important role in the energy market. But also we have to take into account that the nuclear energy present a very low levelized cost of energy in the forecast for 2030 in terms of installed capacity. In the graph that you can see in the right side, you can see that in terms of installed capacity, nuclear energy is with hydropower, and wind energy, the technologies with lowest levelized cost of energy. So I don't know if you can pass to the next slide, Paco. Thanks. And so we already have many data that show the importance of the role of nuclear energy in the energy transition in order to reduce the CO2 emissions when we are generating electricity. But this data have to be communicated to the society, and this is one of the main challenges that we have in the next years. And nowadays we can see on internet many different articles that say that net zero emissions may not be possible without nuclear power, or for instance, in the first week of this year, of this month, the Japanese Minister of Energy say that they need to restart the nuclear program in Japan, because without nuclear energy, they won't be able to achieve the objective of net zero emission of CO2 by 2050. So one of the biggest challenges that we have in nuclear energy for the energy transition is to communicate this fact to the society, that nuclear energy has to play a very important role for reducing the CO2 emissions, because if we phase out our nuclear power plants, we will have to burn more gas or coal. So this is the alternative. So I don't know if you can pass to the next slide, Paco. Yeah, and the importance of these hot topics is not new. For instance, in 2019, the International Atomic Energy Agency already organized an international conference, the International Conference on Climate Change and the Role of Nuclear Power, that also treated this topic of the role of nuclear power in the energy transition. And for instance, I have taken some pictures here about the generation of the electricity generation in Europe and the intensity of carbon emissions per kilowatt hour. And we can observe here how those countries with nuclear power in general emits lower levels of CO2 per kilowatt hour. And those countries with that doesn't have nuclear power emit more CO2 emissions. One example, and the leader in Europe in terms of CO2 emissions per kilowatt hour is Poland, and Poland is thinking in installing nuclear power plants in order to avoid this important problem. But also we have Germany, who is finishing his phase outs. Germany will finish his phase out in 2022. And in Germany, they have a problem, and they are installing a lot of renewable energies, but a very important part of the electricity generation in Germany, more than 20%, is based on coal. So here we have important problems, and we have to take into account that not all the countries have the same potential for installing renewable energies. For example, Norway has a great potential of hydropower, but for instance, Japan, and the Minister of Japan has recognized this fact, as a very low potential of renewable energies. So I don't know if you can pass to the next slide, Paco. So for finishing, I want to say that nuclear power is essential in order to achieve one of the Sustainable Development Goals, the clean and affordable energy. Why? Because nuclear power, if we see the graph in the left side, we can observe how nuclear, when we have long-term operation of our nuclear power plants, has the lowest levelized cost of energy of all the technologies that are available in the market. So obviously nuclear provides a very affordable energy, but also in terms of clean energy, nuclear doesn't emit CO2 gases or greenhouse gases when we are operating nuclear power plants. And if we carry out a life cycle analysis of the different technologies that we have for producing energy, we can observe how nuclear compete with other renewable energies like solar PV, hydropower, or wind in terms of greenhouse emissions per gigawatt hour that is produced by these electricity plants. So nuclear power has to play a very important role in energy transition because is a clean and affordable source of energies that can contribute even to reduce the electricity prices.
Thank you very much, Roberto, for that great summary. I think you have provided some very robust arguments indeed of the relevance that the nuclear power can play in this new ambition targets that frame the energy transition in general. You've given some examples of international cases. I'd simply like to ask you, more in general, how do you see the international framework on countries that are committing already? You've also mentioned others that are planning to or are thinking on it. And what do you think can be the main challenge for the nuclear sector to not be left out of the equation when speaking about energy transition?
Yeah, thanks, Paco. About countries, I think that we have two different policies. One is German. We can say Germany is following a phase out. So in the next, in this decade, we will see the results of this policy, of this energy policy. But in general, I think that countries that are growing in terms of GDP and population are increasing the number of nuclear power plants. We have the examples of China or India, but also we have to think in the future. And the future, for instance, in Europe or in USA is the long-term operation. And as I have shown in the graphs, long-term operation has a very important benefit for the society, and is that the long-term operation has very low levelized cost of energy. So it helps to reduce the electricity prices and can help to improve the economy and the industrialization of these countries. And moreover, we have other countries like Poland or Czech Republic that are thinking in constructing new nuclear reactor, or even Bulgaria or Romania are thinking in this fact. And about the challenges that we have for not lefting out of the energy transition, I think one of the most important challenges is communication with the society. But moreover, we have other important challenges like load following, because obviously we are going to operate in a system with a lot of renewable energy. So we have to be able to improve the load following of our nuclear power plants. And moreover, we have to face other challenges that are more related, for instance, in the future with nuclear batteries that can help to produce energy in very isolated places. So we have a lot of challenges, but in terms of the present, the most close present, we can talk about long-term operation, like the most important challenge with communication.
Thank you very much, Roberto. We've covered right now half of the hot topics. As we were saying, they are 4. Before continuing to the other half, just a quick note on why we have called this event Back to the Future of Nuclear Industry. Indeed, all of these hot topics we were saying that are expected to shape the next decade in nuclear are also in alignment with the motto that we have established for the Congress, which is look ahead. Indeed, we do believe that it's challenging times, but it's very interesting times also for nuclear. We firmly believe that it has a role in the future of energy. We are seeing it, as Roberto pointed out, in countries that are already undertaking nuclear projects. So that's why it's back to the future of the nuclear industry and the look ahead motto that we have for the Congress. Roberto also very nicely touched upon the issue of nuclear batteries. So now we're going to move on to our next hot topic, which is small modular reactors. For this, we have with us Samantha. And indeed, small modular reactors, one of the promises we've been hearing, and that is expected to perhaps be a game changer in nuclear. And to tell us all about it in 5 minutes, Samantha, the floor is yours.
Thank you, Paco. Hi, everyone. Well, in this short talk, in this 5 minutes, my intention is just to give a brief overview of what the SMR projects are now in the world. And just in case there's someone here who doesn't know what an SMR is. SMR is the acronym of Small Modular Reactor. Those are small nuclear reactors that produce power up to 300 electric megawatts. And during the last decades, those have been studied and developed, and nowadays exist around 70 designs now. And those designs are based on a variety of technologies, as could be light water reactors, PWR, BWR, or heavy water reactors. There are also high temperature gas cooled reactors or fast reactor cooled by lead, helium gas, sodium, and there are even generation 4 reactors as the molten salt reactors. And among all these mentioned technologies, some of them are in an early design phase, but many others are already a reality. A clear example of this could be seen in Russia. Here on the right, you can see Russia in the map have several designs, but we may focus in the KLT-40S reactor. There were 2 modules. Those were implemented in icebreakers. Nowadays, they are connected to the grid, giving power to the net. So this thing is not only happening in Russia. Looking to the American continent, there are several advances. That's, for example, it happens with the current reactor, which is located in Argentina. This is a PWR, industrial demonstration reactor, and it is under construction, and it's expected to be finished in 2023. We can also move up to the north of America, and we can see that in the United States and Canada, they have many designs, and there are many that are under development, and they have huge policies promoting the SMR development. For example, we can see that in the United States, and the new scale design was approved by the NRC some months ago, and also Canada has several designs that have already licensed in a preliminary phase. But we can also look to the Asian continent. There, China leads the way. Here we have the high temperature reactor, the HTR-PM. It's a pebble bed reactor. It's in an already an advanced phase of construction. The construction is finished, and it's supposed to start commissioning this year. So it's really a reality. We can also go to Korea. We have the SMART design, and it has been studied worldwide. Many research Institute, and this design has also been approved. But we cannot forget Europe. Can you change, Paco, the slide? We can have a better view of how Europe is in terms of designs. And we can see that nuclear is not dead. There are several designs, and many countries have go for this nuclear SMR. A clear example of that is the United Kingdom, and with the UK SMR, which is in a really advanced design phase. But there are also some other technologies, not only PWR. We can go also to Sweden with the Sealer reactor, which is a fast reactor cooled by lead. Or, for example, we can also go to France with New War reactor, which is in an early phase of design. And with all this information I have given, you may ask, why all these countries have put in faith in, why they are supporting SMR? What this technology has made it so appealing? I may say the answer is in the own name of the SMR, the modular. Being modular allows them to have great advantages. It could be, for example, it could be constructed all the module inside a factory, and it may reduce cost. And also, and not only reducing cost, it can also reduce construction times, reducing cost also. Also being modular gives them the capability of having flexible power, so they can be implemented in the small regions or in big regions, depending on the demand. Finally, the main advantages of the SMR, I may say, is their use in non-electrical applications. If you can change the slide, Paco, we could see some of the applications that can be used. So in these applications, the energy that is produced in the reactor is not only used for producing electricity, it's also used for any other kind of processes, as for example, district heating or seawater desalination, processes like hydrogen production, or even high demanding industry, such as steel making industries. So many applications. And just now to finish, we can see that with everything I have said before, with all the designs that have been under development, are being constructed, we can affirm that small modular reactors are the present and also the future of the energy industry.
Thank you very much, Samantha, for the very nice summary. I have to highlight, I really like the nuclear is not dead phrase when coming closer to Europe. I guess that perhaps some years ago, I could have asked what is the main challenge to actually see SMRs become a reality, but you have already pointed out that they are a reality. So I guess I should ask you more, if apart from all of these wonderful advantages that you have outlined for us, if there's any challenge still you would highlight to make the balance. We've seen 70-ish designs all around. Is there any challenge to make the balance tip from under development to deployment? Which one would you highlight?
Well, the main challenge is the money and the people who can support this kind of technology. But I think that's now, it's not a problem. There are many startups that many companies that are going into, they are supporting SMR. But I think the main challenge, at least here in Europe and maybe also in other countries, but mainly in Europe, the main challenge is the licensing problem. The licensing with all the other older nuclear power plants, they were based in other kind of safety systems. Now the SMR are mainly based on passive safety systems, or things that are not a lot of layers of safety. Now it's different, SMR are different. So I guess it should be, we should looking for which new ideas to see what could be difference in licensing and to promote these kind of features that are intrinsic of this technology.
Definitely. Thank you very much. We're much looking ahead on those developments with those challenges. So thank you, Samantha. And last but not least, let's dive into our fourth hot topic. We have Alex here to tell us all about it. And this is related to the frame of the breakthroughs in materials and nuclear fuels. Indeed, in materials is a field in all of its several areas of application that evolves, particularly nuclear It's evolved a lot since the early days, and it's still doing so. So for that, let's hear all about it in the challenging 5 minutes about materials and nuclear fuel. Alex, the floor is yours.
Hello, Paco. Thank you very much for the introduction. As I only have 5 minutes, I think I'm going to center my presentation more on the second part of the hot topic. So the hot topic is called New Materials and Nuclear Fuel, and I'm going to center on the nuclear fuel part. So I'm going to talk about one of the main central points in the hot topic, which is the development of accident-tolerant fuels, which has been one of the industry's hot words in the last years. So what are the challenges in nuclear energy, and why do I believe that accident-tolerant fuels can really be a game changer in the nuclear industry? Because the main challenges for me of the nuclear industry is firstly to have a higher safety margin, and secondly to lower costs, to be able to compete, as Roberto was saying earlier, with all the other technologies, with all the other energy mix, and with other technologies that are getting cheaper by the day. But essentially, as I put in my presentation, we're using the same fuels since the 1960s. The first PWR plant, for example, started operation in the USA in the 1960s, and nuclear fuel is essentially unchanged since then. So what happens after the Fukushima accident? We realized that actually the Fukushima accident, as you probably know, was by risk of H2 production. H2 explosions. So we realized that, in fact, if we change fuels, if we change nuclear fuel, we can gain safety, and we could have actually stopped the Fukushima nuclear accident. So ATFs can, as I put below in the presentation, on the first part, improve safety, and by the second part, reduce costs. And all the writing that is in blue here is summarized in my next presentation. In my next slide, sorry, Paco, so if you can pass to the next slide. In the upper part, we can see that we have two main changes in ATF fuel. We have a change to the cladding, so what goes around the fuel, that's normally zirconium right now, and we have a change to the pellets, so the fuel pellets inside the cladding. So we have, firstly, the changes to the cladding would reduce corrosion, so reduce H2 production, or increase mechanical strength. So they would actually have less failures by debris in the primary circuit. And if we change the pellets, the actual fuel pellets, we could change the material by doing pellet doping, including other components inside the pellets, apart from the uranium oxide. This would increase the density, so we could get higher enrichment of uranium and longer cycles. And this would also reduce thermal conductivity in the material, so we would have lower temperatures. So we could maybe produce more power and keep the temperatures lower, increasing safety. And what I have put in orange here is a very interesting concept that I think is interesting that we can also see in the graph below. That for me, we have a classification into two types of ATFs. First, we have evolutionary ATFs, which are the ones that change very little, or well, change some things with respect to the fuel that we are using nowadays. So, for example, this would be a coating, adding a coating to the cladding, to the outside of the fuel rods, or adding doping to the pellets. But the materials, the essential materials, would remain the same. And then we have revolutionary ATFs, which would come into operation in a longer period of time. They would come into operation in the next 20 years, maybe 30, and they would imply really big changes to the material. So they would have a change in the material of the cladding, complete change in the material of the cladding, or a change in the actual pellets. So a different material would be used to create the pellets. And here we have a small graphical representation that I've found in the internet, in the NEI. So this is, I have to say, a bit, it was done in 2017, so this has been a little bit delayed with respect to the dates that appear in the presentation, but I think this is a small overview of ATFs.
Thank you very much, Alex, for that nice overview. For what I'd like to ask you real quick is the ATFs that you've been mentioning and that indeed are a hot topic, and we might expect to see more of them all around. They are currently being actually used. If you could tell us a bit more about that. And also, what about perhaps one other area in which materials themselves are expected to develop a lot in nuclear outside the scope of ATFs?
Well, for ATFs, actually, the first part of the evolutionary ATFs, the ones that you can see at the top left, are actually being tested right now with something that we call LTAs, lead test assemblies. So they are actually operating for the first time inside nuclear power reactors as a test. And we are going to see what the radiation is doing to them. And we hope to, this is like one of the first steps in the licensing of the, well, not the first steps, one of the final steps actually, in the licensing of these ATFs. And for the second part of your question, which is for the other areas in which new materials can have an impact, well, we have many areas from current nuclear power production plants, where, for example, different alloys, metallic alloys are being developed, or different concretes or cements are being developed to withstand radioactivity, all the way to metals for fusion power plants. Or very interesting, actually, we have already received some paper submissions for Generation 4 reactors, special materials that are being developed specifically for Generation 4 reactors, like for dual fluid reactors, which will withstand up to 1,000 degrees Celsius. This will be ceramic type materials, or for also for Generation 4 reactors, different kind of metals that will be used, and also for nuclear batteries. We have also received one submission of a paper for nuclear batteries, as Samantha was saying earlier, that use actinides to create luminescence in kinds of crystals that can be used in nuclear batteries. So very interesting, a very wide range of topics for materials.
Thank you, Alex. Indeed, really interesting. I take the chance that you mentioned it, that we've put the pressure, let's say, on our hot topic managers to, as a kind of teaser, tell you the main things of each of the hot topics. But of course, the scope is wide. There's a lot of things to be discussed and to be done. And this is one of the keys for or one of the big added values of attending ENYGF. Not only, as Alex was pointing out, we are already receiving papers and work of our young colleagues in these areas, but also we aim to bring together the key experts in those areas, research institutions, companies, so that when we get together in September in ENYGF, we can really dive in to all of the areas and challenges and work that is actually being done in all of these hot topics. So once again, let me appreciate the effort of our hot topic managers in putting all of this together. We're now going to step into the Q&A mode. We see that we have several questions from the audience, and I'm going to go addressing them to each hot topic manager. Some might also be open so that several of you might provide parts of the answer or even debate upon it. And now that we don't have to be so rushed with the 5 minutes, each time we go to a hot topic manager, I will ask him or her to introduce himself a bit more personally, tell us also what they do. I won't say that you have 5 minutes to do that. You can take a bit less if you want, but also so that you get to know them a bit more personally. So let's start with I'm going to go in order of chronological order as we have received them, I think, or no, it's also weighing in the votes. So you know that you can also vote the questions that your fellow viewers are submitting. The first question from Laura Ortega. Thank you very much for submitting your question. It's going to go for the first hot topic we had today, David. Question says, machine learning algorithms seem a rapid and feasible way for predicting patterns and handling big data. Could this be used in the useful way within radioactive waste management issues. So machine learning in rad waste and closing the circle. What do you think, David?
Hello again. It's a nice question, I would say again. First, I introduce myself, as I understand, no, Paco?
Yeah, please,
Okay,
go
so
ahead.
I'm David Garcia. I'm a chemist. This is my background, and I hold also a PhD in chemical engineering. I'm working for a consultancy company located in Barcelona, in Spain, which is Anfos 21, and I'm the manager of the chemical division, let's say, within the nuclear department. I've been working there for almost 13 years, basically working in radioactive waste management issues, but not just radioactive, also other kind of chemical problems that companies have to deal with. And specifically, I've been working a lot for DGR, for these waste management agencies that are interested and investing in this kind of systems. Regarding the question about machine learning, it's a very nice, and it's trendy. I mean, if you remember, I guess that some of you were in this last Spanish Nuclear Society meeting. There was a presentation, for example, about machine learning issues by a spin-off company, a very young company, that they were trying to make things with machine learning in this area, and it's very promising, I will say. There are also different European actions that are already working on this. So, for example, there is one project, which is a very big project also, called PREDIS, which is a predisposal. It's focused on predisposal things, predisposal of radioactive waste management. For example, there is one of the things that we are doing there. It's preparing a digital twin for a waste package. So there is a waste package. The agencies would like to know how this will behave in the future, and if any kind of change in the composition of the waste package or of the waste, for example, may induce any kind of problem, long-term problem for the waste package. So for this, for example, we are in this project. I know that some people is working and preparing a digital twin based on machine learning. So you train a machine that will be later used for predicting this in a very rapid and easy way, because these kind of calculations will take a while. If we use this kind of approaches like machine learning, calculations are performed before for simplified systems, and then you can apply this to big systems, which is easy for solving the problem. So for this, for example, it's already ongoing. And if we go, for example, also to to the very small scale, not so big like a waste package, there is also other people who is using these machine learning algorithms to make difficult calculations. For example, for corrosion of the metallic materials. There is some people who is making these machine learning calculations to avoid or to simplify the calculations as much as possible and consume the less time as possible for making it. So it's important, and I think that it's very promising in this area for the radioactive waste management.
Brilliant. Thank you for the answer. I guess that Laura's question is answered with that reply. I'm going to switch a bit the order because in more or less 15 minutes our dear Roberto will have to leave the meeting. So I'm going to give a bit of preference for those of you who have asked within his hot topic so that he can address them. And then we can also continue with the others, but we'll go swiftly changing from topic to topic. It's a question from James Blades. Thank you, James, for submitting it. It says, thanks for the presentation, Roberto. You have given several technical arguments, but those do not always turn the public perception. Do you think Fukushima kills the hopes for a nuclear renaissance?
Okay, thank you, Paco, and thank you, James, for the question. Obviously, the Fukushima accident had a very important role in the has had a very important role in the development of nuclear energy in the last terms. But I think that I don't know how to say it. the most important danger, or yeah, we can say that Fukushima has not killed the nuclear renaissance, but has paused the development of the nuclear renaissance. Why? Because many countries like China or India, for instance, stopped the nuclear programs in order to carry out new safety reviews. So we can talk that obviously Fukushima accident has not killed the nuclear renaissance, but have stopped many projects. And also it's very important to say that the German phase out was accelerated due to the Fukushima accident. So from my point of view, we have to think that Fukushima doesn't kill hope for nuclear renaissance, but has postponed many projects. And nowadays we are watching this nuclear renaissance in many countries in Europe, for instance, in Czech Republic or Poland or Bulgaria. Bulgaria is a very good example nowadays. But I think that a key point, a very important point in the development of the nuclear industry will happen in 2030. Why? Because 2030 is the year of the most important milestone in the European roadmap for getting in 2050 the reduction of the 80% of the CO2 emissions related to the electricity generation. So in 2030 we in Europe have not gotten to reduce the CO2 emissions in many countries. Nuclear energy will have an important renaissance. So I think that 2030 is a very important year in this nuclear renaissance. So yeah, I think that Fukushima has only postponed many projects, but nowadays China, India, Turkey, they are building nuclear power plants. So I think that nuclear has future and will have more future from 2030. 2030 will be a very important year.
Great, thanks for that. Let's deposit our trust in this crystal ball vision that Roberto has given to us, but very well argued. And let's join as a follow-up for this question. And let's start by you, Roberto, and then let's open up for the rest of the managers to also give their insights on this. It's a question from Pavel Yakovlev. Thank you, Pavel, for submitting it. The question is there an opportunity in Europe for nuclear to be accepted as viable green technology to fight global warming in addition to solar and wind? So Roberto, and then the rest of the hot topic manager. This is a good one. Thank you, Pavel.
Thank you, Pavel. Yes and not. Why? Because the European Union has only said that nuclear energy is a very important pillar in the energy roadmap of the European Union, but each country can have its own energy policy. So for instance, in Finland, we have that the Green Party in Finland has said that nuclear is a green energy, a green technology, and that most important part that we have to take into account is decarbonization. But on the other hand, we have Germany, and Germany thinks that not, and Germany is finishing the nuclear phase out. So this part doesn't depend on the European Union. This part to accept nuclear as a viable green technology depend on each country. So this is a very difficult question because, for instance, if we talk about UK or we talk about Finland, the answer is yes. But if we talk about Germany, the answer is not. And the European Union cannot say to each country what each country has to do for achieving the reductions of the CO2 emission. So each country has its own policy. However, as I have said before, 2030 will be the most important year in the development of this energy roadmap by the European Union. And if the European Union see that in 2030 the policy, the energy policy that has developed Germany is not the best one, I think that in general the European Union will decide to accept nuclear energy as a viable green technology. But I think that for a common answer of the European Union, we will have to wait until 2030. Until that moment, we have countries like Finland or UK that I think that consider nuclear energy as a viable green technology.
Thank you, Roberto. Samantha, what do you think? Do you think in the SMR field it is very necessary to put a sticker that says green in the reactor vessel, or is that not much an effect with the SMRs?
Well, I think it would be super, it would give to the public a nice view if that says green. But I guess, of course, it's going to help SMR development if a population is it's going towards this energy. Of course, countries are going to have policies that promote this kind of energy. But yeah, it may help, but maybe it's not needed. There are so many countries that they have never had nuclear, as for example, Estonia, and they are going towards nuclear and SMR. So maybe it's needed, maybe it's not, but of course it would help. It would help.
Yeah, definitely. In that regard, I think we're kind of the whole Europe is orbiting on seeing what the final taxonomy and the Green Deal is going to look like. Recently, last week in the SNETP forum, the person speaking from the Commission was mentioning that the status right now is depending on the JRC, the joint. It's the research institution for the European Commission's evaluation for that. So we're all kind of pending on that to see also what the paper says in the end. No, so definitely we have to keep an eye on all of that. And thanks Samantha for your answer. I see the hand up of Alex.
Yes, Paco, as you were asking for our opinions for the rest of the managers, I would like to say that for me, the answer to Pavel's question is that clearly, yes, of course, nuclear can join in the fight for green energy, especially because solar and wind are clearly intermittent energies. No, when we don't have wind or when we don't have solar, or when we don't have the sun that is shining, these energies are not producing any energy. So we need some other base energy that can produce energy whenever we want it to. And the problem with this is that we have either nuclear that can produce whenever we want, or fossil fuels. And fossil fuels are not good for our CO2, for our necessities of emission of CO2. So they produce climate change, as we all know. So if we want a full green energy, and we want to have the climate objectives, we want to fulfill them, we need a certain mix of nuclear energy. I'm not going to say that my opinion is that there should be 100%, but any country that doesn't have a bit of nuclear energy will be using fossil fuels to cover up for the renewables, unless they have, for example, hydroelectric power, which is something that some countries do and some countries don't. We can't produce hydroelectric power wherever we want it to. So for countries like Spain or like most of Europe, you either use nuclear or you use fossil to cover all your needs of base. So of course, for me, nuclear is the better alternative and can help in the fight for greener energy.
Thank you very much, Alex. All right, so more. Thank you, all of our viewers, which are being really active with the questions. Let's see if we can perhaps think about some extra 15 minutes and see if we can touch upon all of them. I think we can. So challenge accepted. Let's go for it. Let's return to David. We have James Blade. Thanks, James, again. He says, norm wastes are a priority issue at European level. What do you think it could be done to improve the management strategies of such waste? So all of these famous, just in case someone in the audience doesn't know the acronym, the norm, naturally occurring radioactive materials produced as byproduct from several industrial processes. They are around, they have to be dealt with, and what would be your view on it, David?
I will pass the floor to Alba, which is more expert on this topic.
Apologies, because Alba and David, I see them as the same person, but indeed, obviously, they're two physical persons, but they are our experts in the waste area. So Alba, welcome to the floor. Let's hear it from you.
Thanks, Paco. Yes, indeed, norm waste are a big challenge nowadays, and it's of course a priority in Europe, because I think that one of the main reasons is this, because not all countries are carrying out maybe not pretty good management strategies for dealing with this kind of waste, as they are not compiled in the radioactive policies. So I think that the first challenge in European level is to put a name on that norm with specific characteristics, so that all countries can identify what is a norm waste, and after that they will be able to decide how this type of waste can be managed. If they don't know they are working with norm waste, they cannot know how to deal with them and how to process them, how to treat them, and how to dispose them. So there are some countries that has already some policies for the management of this type of waste, but others like Spain, not yet. So they are working on that, but this is still not running, as we could say. So I would say that a good characterization of this kind of waste and to be able to identify it.
Thank you. So room still on that area for things to be done. Thanks for that answer, Alba. All right, let's go to more questions. Pavel, thank you for your appreciation there. We salute you. Let's see. Okay, we have. Okay, back to votes, because now I'm getting them all mixed up. From Eduardo Kuok. Thank you for the presentations. So what are your argument for advanced nuclear over current nuclear system? Given the concern of the time scale regarding net zero or negative by 2030. So if I can rephrase that, advanced nuclear over what we already have and is working. I leave it open. So the first one to unmute itself, take it.
Okay, I can go ahead. I was leaving because I've spoken a lot and I don't want to. For me, the concern over new, if the question I think is why would we put efforts into developing generation 4 reactors, and what will they give compared to nuclear? If I've understood it well. For me, the problem is the licensing. If we have a very long licensing period in nuclear energy, when we want to develop something, we can be 20, 30 years developing it, licensing it, doing all the tests, and even though we have concepts that have very good concepts that would have would give us new improved capabilities, improved security, reduced costs, we don't put them into operation because we prefer to use what we know, because we are partly scared and we have very big controls on nuclear energy. So for me, this is a very interesting question, because I'm always hoping that someone like Elon Musk or something like this will come into nuclear energy and will be a game changer for nuclear energy, for all the process that we do in licensing, like Elon Musk has done with SpaceX or with Tesla in those industries. And we can have innovative ideas and not keep on using the same reactors, which work perfectly fine. But we like to play it safe, let's say, and this is, I think, what will determine if we go on to generation 4 reactors or not.
Thank you, Alex. So we'll definitely pass on to our communications team so they can reach all of the hotness of these topics that will be treated in Tarragona. See if we can reach Elon Musk should he be interested also to come along, of course. Thanks for that. Let's come back to the questions. That's one that is a bit tied to what Alex was talking about right now, from an anonymous spectator, but we obviously will answer all of them. Says, Samantha, this one is for you. Which are the main pros of having several SMRs instead of one reactor with standard power of 1000 megawatts? And I will add from my personal side, are they mutually exclusive or not? Can they go hand in hand?
Muted. Yeah, no, they are not. I mean, they can go. The question is, the answer is wide. I think the main pros of having just one SMR reactor instead of the generation 2 reactors, the ones that are already producing energy, is I can say is the versatility. So with just one small modular reactor, not one, sorry, when you have a bunch of modular reactors, you can use them for different applications, something that you cannot do now. Now you produce the energy you produce, 1000 megawatts, and that's what you produce. You cannot change it. And even in some countries, like for example in Spain, you cannot even move to the demand. Is what you produce, what you have is everything what you have. You cannot change it. So with SMR, what you can do is you can adapt. You can use it for having a lot, producing energy, or you can use some of them for producing these non-electrical applications. They can be used for, I don't know, for the application I have said before, or they can be used for producing energy. So I think the advantages is the economy of scale, and also the adaptability they have for using it in other applications rather than use it for electrical production.
Thank you, Samantha. I guess that that also answers. We have now with a lot of votes, Laura Ortega's question on SMRs. If you truly believe they will be a game changer, or that Gen 3 reactors were very promising in the 2000s, but only China has these reactors in commercial operation, and what would make an SMR different? I think that with this answer of all of the varieties and applications that they may have, it's addressed. If it's not addressed, Laura, feel free to look for the detail that you are perhaps after. Or if you want to add something to that, Samantha, I think you more or less covered it.
Yeah, I truly agree with you. I think it's already answered. It's this adaptability, this flexibility of being used in different applications. It's what they give. They could be a game changer. Also, the promise of having reduced costs and being needed, the time needed to construction could be less. It's not yet proven. There's the cases that the reactor that has now being constructed, the one in Argentina and the one now in China, those are demonstration reactors. Those are really, they are going really well, but the promise of having reduced cost is what is really make SMR a game changer. And also, I think the generation 3 reactors, the main problem was first the licensing, as may happen with the SMR, but also the need of money. They need a great investment, and many countries didn't have that money, and many companies didn't want to invest that money. So with SMR is different because the scale is smaller.
Thanks. Thank you, Samantha. Right, now, Alex, back to you. I'm merging two questions together, one anonymous and the other one from Antonio Jimenez Carrascosa. They are the following. Apart from thanking for the presentation, which factors do ATF's implementation depend on? And the other part is, what are the most promising ATF technologies? So the factors to implement them and the most promising technologies as such.
Okay, so I will try to give a short answer to each of the questions. The factors is very similar to what I said before on why generation 4 reactors, if they can or cannot be the future. Actually, if we are going to implement or not ATFs, this is going to be a business decision. So if they are cost effective, if the benefits are greater than the costs, then we will implement them. And the problem with ATFs, as with any development in nuclear, as I was saying before, is that they have a long and expensive research and development program. And they have a long licensing period because, as I was saying, in nuclear, the licensing periods are very long. So this creates a very high cost for ATFs, and the more different they are to current reactors, the higher this cost is. So this will mainly depend on if we have a life extension for the plants, because we have many plants that are currently working whose life finishes in 10, 20 years. So is it effective to develop an ATF when we only have, for example, in the US, if they don't do life extension, which many plants will do, but if they wouldn't do that, would it be effective to invest so much money in something that is going to operate for not a long period of time or not? So these are the factors that will determine. And as I was saying in my presentation, of the two types of ATFs, my bets are probably on the evolutionary part, not the revolutionary part, which would be a complete change in fuel, because the evolutionary ATFs are currently already being tested. So I hope to see some in full operation. They're already inside our reactors as tests and operating and producing power. But I hope to see full reactors with this kind of fuel for the 2030s, so in 10 years' time. And the second question was the main technologies. This is it was of ATFs also, Paco? The main ATF?
Correct. Yep.
Okay, this is a very wide question, but I would say that for the evolutionary ATFs, so it is currently CR coatings that are being tested. This would increase especially the resistance to corrosion and the mechanical strength. We also have FeCr Al materials that are being changed for the fuel, and also we have doping of the fuel pellets. So we have uranium oxide that's being doped with chromia or alumina that will change the pellets. And for revolutionary ATFs, so ATFs that we hope to see in a longer time period, let's say, not very, very long, we have SiC ceramics for the fuel structural materials, and we have U3Si2 pellets, which would substitute the UO2 that we currently have for U3Si2. So this would be a larger change than evolutionary ATFs. I don't know if a lot of technologies.
Thank you very much, Alex.
In the hot topic.
Thank you very much, Alex. See, this is what happens when you open the box with Alex. That indeed you can see that our managers dive into the subject a lot. But we have to say part of it for Tarragona also. So, but thank you for that answer. I take it that it answers the question. We have now one here from Eduardo Kuok. Knowing him and knowing the passion he has for the sector, I'm not surprised for the detail that he is posing. How do we modernize the reinsurance pool for SMRs? Now, I don't want to put anyone here on the stake because it is a pretty detailed question. What I can tell you, apart from obviously encouraging you to come along to Tarragona, is that we do have colleagues in Jóvenes Nucleares that actually work for the insurance pool in Spain, and it's something that definitely, with the experts that will be accompanying us to the sessions of the hot topic in Tarragona, can be covered. Unless some of the managers want to add something to this, I would thank you for the question and leave it there, because I am also particularly interested on that area. SMRs or non-SMRs related, I have to admit that it's an area that I take for granted, but I do not know the details of. So unless any manager wants to step in, we invite you to come to Tarragona and let's find out there. Thank you in any case, Eduardo, for that question. Now we have James Blades. One more question for Alex. Is there ATF technologies more promising than other? Will we see actual ATFs, not enhances fuels, improving in the safety and performance of Gen 2 reactors. So in the promising one than the other, I think that you gave us your bets in the previous answer. Perhaps here we can tackle the second part of James' questions. Will we see actual ATFs improving the safety and performance of Generation 2 reactors?
Yes, of course. For me, the part that he was asking if the difference between enhanced fuels and ATFs, actually ATFs are enhanced fuels. There's no difference. They're just called accident tolerant as a bit of a catch name, because it's something that enhances the fuel, enhancing its tolerance for accidents. And yes, of course, I think we will see them in our Generation 2 reactors. For example, the company that I work in USA in Spain already has lead test assemblies in reactors in Europe. So I hope to actually see them in operation in the 2030s. And these lead test assemblies, and my personal bet for which we will see in operation is especially coatings and doped fuel pellets, as I was saying earlier.
Nice, thank you. And we have a final question, which I guess we'll split between ATFs and SMRs, which says, is there any concern about the use of ATFs in SMRs? So can both advantages be combined? I'm adding that. What do you both think? ATFs in SMRs. Or actually, I would add, is there any SMR design that is already considering ATFs as kind of coming in the original design?
Sorry, I have a cat issue now. Actually, I think SMR, there are some SMRs, as for example, the PWR. Those are reactors that are using proven technology. They are not inventing anything. There's already proof. So implementing this ATF fuel is not out of the vision of in the reactor. So those can be implemented. So there's no restriction. Is what at the beginning years ago with MOX fuel, it was saying it could be used. Yeah, it could be used. So the same with ATF fuels.
Nice.
Exactly.
Alex.
I completely agree with what Samantha was saying, because actually the ATFs are just an evolution of the current fuel. They're actually operating right now in nuclear power plants that work exactly the same as others. So if the SMRs are designed with a PWR in mind, of course they can use the same fuel.
Brilliant. Okay, so if I'm not mistaken, we wouldn't have any questions pending. I don't see that, but let us check that we're not leaving anything behind. More or less, we're more or less in the time that we had in mind. Whilst we get that confirmed, let's see. So obviously we've had some very interesting questions. So again, thank you for all the viewers for actively participating and submitting your questions. Obviously from the other side, for our hot topic managers for preparing those topics and addressing the questions. You can see them in the screen, the 4 hot topics that are shaping the 2021 edition of ENYGF. So we can't stress enough how much we would like to see you in Tarragona or in hybrid. You know, we're being very flexible with this as the situation asks us to, and welcoming you to submit your work or to register for the event, because as we were mentioning before, this is really bringing together all the young professionals, with also, we hope to see Samantha's cat there too, with also all of the experts in these areas, from research and from industry. That being said, obviously we also have the program of technical tracks for all of the other very interesting also technical fields that nuclear extends itself to. And with that, let me check, because now I see something in the questions. No, we had this one answered. I'm in the chat just in case someone put something here, but I think we do not owe anyone a response. In any case, obviously there's much more to be spoken. We can get into much more detail, and that's why we're waiting for you with our with all of the care and the preparations that our teams are doing, and hoping to see you there. I have to thank also Charlie, which is our Troy McClure from the Young Generation Network. You might remind him from other congresses or seminars. He has been helping us out in the backstage with this one. Thanks, Charlie, for that. You see in the screen the website of enygf.org for all of the information on the agenda, on all the other surrounding activities we're planning and how to register, etc. And to close the session, again, thank you, everyone. Look ahead, which is the motto we are establishing for ENYGF. Let's stay tuned for more on this hot topics. We're really looking forward to see them thrive in the next decade. And in order to enjoy that progress, we must know about them, see the challenges, and get a great opportunity to dive into all these areas. So with that said, again, many thanks to all the managers for your time, and for all the viewers for assisting. Stay tuned with us through social media. Reach us out whenever you have questions, and stay safe. Thank you, and we keep in touch.